The year was 1847 when a young Scottish immigrant named Daniel Massey stepped onto Canadian soil with nothing but determination and a vision that would eventually feed billions of people across the globe. What drove this ordinary man to believe he could revolutionize agriculture? The answer lies in understanding the desperate hunger crisis that gripped the world during the mid-19th century, a time when farming was still done by hand, and entire populations faced starvation with each failed harvest. Daniel Massey began manufacturing agricultural implements in a small workshop in Newcastle, Ontario, creating tools that seemed simple but represented something far greater: the promise that human beings could finally break free from the ancient struggle against famine. His early plows and harrows were crude by modern standards, yet farmers recognized immediately that these tools could multiply their productivity tenfold. But why did Massey succeed where countless other inventors and manufacturers failed? The secret was not just in the design of his equipment, but in his understanding of what farmers truly needed in their daily battle against soil, weather, and time. By the way, if you're passionate about these stories of engineering, strength, and industrial heritage, here you'll discover documentaries about legendary tractors, colossal machines, and the equipment that transformed agriculture, mining, and construction. Subscribe, and every week we'll explore together how these machines change the world and the way we work. After this, we continue with the remarkable journey that would transform a small workshop into an industrial giant. When Daniel's son, Hart Massey, took control of the company in 1856, he brought with him an obsession that would define the company's future: constant innovation through acquisition and improvement. Hart understood something profound about industrial competition that many of his contemporaries missed entirely. What was this crucial insight? He realized that the future belonged not to those who invented everything themselves, but to those who could recognize genius in others and incorporate it into a unified vision. This philosophy led him to purchase several smaller implement companies, absorbing their patents, their knowledge, and their best craftsmen into the growing Massey enterprise. The 1860s brought the American Civil War, and with it came an agricultural crisis that nobody had anticipated. Southern plantations lay abandoned, while northern farms struggled to produce enough food for both civilians and soldiers. How did this distant conflict transform Massey's destiny? The war created an unprecedented demand for mechanical farming equipment, as women and older men left on farms desperately needed tools that could replace the labor of young men who had marched off to battle. Massey's factories worked day and night, producing thousands of implements that were shipped across the border to feed the Union's war effort. But Hart Massey was not content with merely selling more of the same products. He became fascinated with a revolutionary machine that was being developed in the American Midwest: the mechanical reaper. This device promised to do the work of dozens of men with scythes, harvesting grain at speeds that seemed impossible. Why did the reaper represent such a pivotal moment in agricultural history? Because for the first time in 10,000 years of farming, human beings could harvest more grain than they could plant, fundamentally changing the economics of food production and making famine a problem of distribution rather than production capacity. In 1870, Massey made a decision that would echo through generations. He began manufacturing reapers under license from American inventors, bringing this transformative technology to Canadian farmers who had never seen anything like it. The early reapers were temperamental, machines that required constant adjustment and frequently broke down in the field, leading many farmers to question whether these complicated contraptions were worth the investment. How did Massey overcome this skepticism? He established a revolutionary concept: a network of trained agents and mechanics who could not only sell the machines but also maintain and repair them, creating the world's first comprehensive agricultural equipment support system. The 1880s marked a period of rapid expansion and consolidation in the agricultural equipment industry. Competing manufacturers engaged in fierce patent battles and price wars that drove many companies into bankruptcy. Massey survived by focusing relentlessly on quality and customer service, understanding that farmers would pay premium prices for equipment they could trust. But what about the workers who built these machines? The Massey factories in Toronto became known for relatively progressive labor practices, offering wages and working conditions that were superior to most industrial facilities of that era, creating a skilled workforce that took pride in their craftsmanship. Then came 1891, a year that would transform Massey from a successful Canadian manufacturer into a global agricultural powerhouse. Hart Massey negotiated a merger with A. Harris, Son and Company, creating the Massey-Harris Company with assets valued at over $5 million, an astronomical sum for that time. Why was this merger so significant? Because it brought together not just factories and patents, but two complementary visions of agricultural mechanization. Massey's focus on reliability and service, combined with Harris's innovative engineering and international sales networks. The newly formed Massey-Harris immediately set its sights on global expansion, establishing sales offices and distribution networks across Europe, South America, and even the distant colonies of the British Empire. What drove this aggressive international strategy? The company's leaders understood that agriculture was fundamentally the same everywhere. Farmers needed to plant seeds, cultivate crops, and harvest grain, regardless of whether they lived in Manitoba, Argentina, or Australia. This universal need meant that a company that could solve these problems efficiently would find customers on every continent. As the 20th century dawned, Massey-Harris faced a new challenge that threatened to make their entire product line obsolete. The internal combustion engine had been invented, and visionary engineers were beginning to imagine tractors that could pull multiple implements while providing their own power. Would these mechanical beasts really replace horses and oxen? Most farmers remained skeptical, pointing out that horses could reproduce themselves, ate grass that grew naturally in pastures, and had served agriculture faithfully for thousands of years. Why would anyone invest enormous sums in complicated machines that required expensive fuel and expert maintenance? Massey-Harris initially responded cautiously to the tractor revolution, choosing to wait and observe, while other manufacturers rushed to market with unreliable and often dangerous early models. This patience proved wise, as several competing companies were destroyed by lawsuits and reputation damage after their tractors killed or injured operators. But the company was not idle during this period. What were Massey-Harris engineers doing while competitors struggled with early tractor designs? They were meticulously studying every failure, documenting every flaw, and preparing to enter the market only when they could offer farmers something genuinely superior. World War I arrived in 1914, bringing with it a desperate need for increased food production to feed millions of soldiers and civilians across war-torn Europe. The British government issued urgent appeals for more wheat, more meat, more of everything that grew or grazed on farms. How did this crisis accelerate the mechanization of agriculture? Millions of farm workers enlisted or were conscripted into armies, leaving fields that needed tending with no one to tend them. Tractors suddenly transformed from expensive curiosities into absolute necessities for national survival. Massey-Harris seized this moment, ramping up production of harvesting equipment while also beginning serious development of their own tractor designs. The company's engineers worked around the clock, testing engine configurations, transmission systems, and power takeoff mechanisms that could reliably transfer mechanical power from the tractor to various implements. Why was reliability so crucial during wartime? Because a broken tractor during harvest season could mean the difference between a filled granary and a failed crop, between adequate food supplies and starvation for soldiers and civilians alike. The 1920s brought prosperity and expansion as Massey-Harris established manufacturing facilities across North America and Europe. The company's first truly successful tractor appeared in 1920, a machine that combined lessons learned from years of observation with innovative engineering that addressed the most common complaints farmers had about earlier models. What made this tractor different from its competitors? It featured a lower center of gravity that reduced the risk of deadly rollovers, a more intuitive control layout that farmers could master quickly, and a modular design that simplified repairs and parts replacement. Sales exploded as farmers who had resisted mechanization for years finally found a machine they could trust with their livelihoods. Massey-Harris tractors began appearing in fields from Saskatchewan to South Africa, from France to New Zealand. The company's distinctive red paint became synonymous with reliability and power, a badge of quality that farmers recognized instantly, but success brought new challenges that threatened to undermine everything the company had built. What was this looming threat? The Great Depression arrived in 1929, destroying markets and bankrupting customers across the agricultural world. Farm prices collapsed as global markets seized up, leaving millions of farmers unable to pay for equipment they had purchased on credit. Massey-Harris faced a crisis that could have destroyed the company. Warehouses full of unsold tractors and implements, mounting debts from customers who could not pay, and a shrinking market that seemed to offer no hope for recovery. How did the company survive when so many competitors went bankrupt? Management made the painful decision to slash production, lay off workers, and focus exclusively on maintaining relationships with dealers and customers who might still be viable when the economy eventually recovered. The 1930s were years of brutal survival, but they also forced Massey-Harris to innovate in ways that would define its future. Engineers developed smaller, more affordable tractors that cash-strapped farmers could actually purchase, creating machines that delivered essential functionality without expensive features that buyers could not afford. What was revolutionary about this approach? The company discovered that simplification and cost reduction required more sophisticated engineering than adding features and complexity, a paradox that transformed their design philosophy. World War II erupted in 1939, and once again agriculture found itself thrust into the center of global conflict. Britain stood alone against Nazi Germany, desperately needing food imports from Canada, America, and other allies to keep its population from starvation during the submarine blockade. Massey-Harris factories converted to wartime production, manufacturing not only tractors and implements, but also components for aircraft, tanks, and other military equipment. Why did governments consider agricultural equipment as important as weapons? Because armies march on their stomachs, and civilian morale depends on adequate food supplies even more than it depends on military victories. The wartime years saw unprecedented technological advancement as military research into engines, hydraulics, and materials science produced innovations that would transform agricultural equipment. Massey-Harris engineers eagerly incorporated these advances into new designs, creating tractors with more powerful engines, more sophisticated hydraulic systems, and more durable components than anything available before the war. What specific military technologies found their way into tractors? Lightweight aluminum alloys developed for aircraft, improved welding techniques from tank manufacturing, and hydraulic systems based on designs used in bomber turrets all became standard features on post-war agricultural equipment. As World War II ended in 1945, Massey-Harris stood poised to dominate the global agricultural equipment market. The company had emerged from the conflict with full order books, experienced workers, and technology that was years ahead of most competitors. But the post-war world presented challenges that nobody had anticipated. What were these unexpected problems? Millions of former soldiers returned home to take up farming, creating explosive demand that temporarily outstripped manufacturing capacity, while simultaneously, rapid urbanization in developed countries began drawing young people away from agricultural communities, reducing the future customer base. The late 1940s saw Massey-Harris making aggressive moves to secure its position for the coming decades. The company acquired manufacturing facilities in France and Germany, recognizing that European reconstruction would create massive demand for agricultural mechanization. They invested heavily in research and development, establishing engineering centers that focused on everything from engine efficiency to operator comfort. Why did operator comfort suddenly matter when farmers had endured harsh conditions for generations? Because mechanization was making farming less physically demanding, but more mentally exhausting, as operators spent long hours concentrating on machinery operation rather than the simple, repetitive tasks of manual labor. In 1953, Massey-Harris merged with Harry Ferguson Limited, creating Massey-Harris Ferguson and bringing together two giants of agricultural mechanization. This merger combined Massey-Harris's manufacturing scale and distribution networks with Ferguson's revolutionary hydraulic three-point hitch system, a technology that transformed how implements attached to tractors and fundamentally improved their functionality. What made Ferguson's three-point hitch so important? It allowed implements to be raised and lowered hydraulically, maintained consistent depth during operation, and transferred implement weight to the tractor's rear wheels for improved traction, solving problems that had plagued tractor implement integration since the earliest days of mechanization. The newly merged company faced immediate challenges as they struggled to integrate two very different corporate cultures and product lines. Ferguson dealers resented Massey-Harris products, while Massey-Harris dealers viewed Ferguson equipment with suspicion, creating a distribution nightmare that threatened to squander the merger's potential benefits. How did management resolve these conflicts? They made the difficult decision to gradually phase out competing models while introducing entirely new designs that incorporated the best features from both heritage brands, creating a unified product line that could satisfy customers from both camps. The 1950s and 60s marked agriculture's golden age in developed countries as farmers enjoyed rising incomes, expanding operations, and seemingly limitless potential for growth through mechanization and chemical inputs. Massey Ferguson, having shortened its name in 1958, rode this wave of prosperity by offering increasingly sophisticated equipment that promised to make farming easier and more profitable. Tractors grew larger and more powerful, combines became massive machines capable of harvesting hundreds of acres per day, and specialized equipment emerged for every conceivable farming operation. But what was happening to small farmers during this era of agricultural industrialization? The economics of mechanization created relentless pressure toward consolidation, as farmers who invested in expensive equipment needed more land to justify the costs, driving them to purchase or rent neighboring farms from operators who could not afford to keep pace with technological advancement. This transformation raised profound questions about rural communities and agricultural sustainability. Was the mechanization that Massey Ferguson championed ultimately destroying the family farm? The company's leaders insisted they were simply responding to market forces and farmer demands, but critics argued that equipment manufacturers were actively promoting a model of agriculture that benefited large operators at the expense of smaller ones. The 1960s saw Massey Ferguson becoming truly global, with manufacturing facilities on 6 continents and sales in virtually every country that practiced mechanized agriculture. The company's tractors worked rice paddies in Asia, wheat fields in North America, cattle stations in Australia, and everything in between. This international presence created unique engineering challenges. How could one company design equipment that worked equally well in tropical heat and Arctic cold, in dense soils and sandy loam for subsistence farmers and industrial operations? The answer lay in modular design and regional customization, creating core platforms that could be adapted with different engines, transmissions, and features to suit local conditions and customer needs. The 1970s brought the first oil crisis, shocking agricultural sectors that had become dependent on cheap petroleum for both fuel and chemical inputs. Tractor manufacturers suddenly faced customers demanding radically improved fuel efficiency, while also wanting more power to operate ever larger implements. These contradictory demands seemed impossible to satisfy simultaneously. What innovations allowed Massey Ferguson engineers to square this circle? They developed more efficient engine designs, improved transmission systems that allowed operators to match engine speed more precisely to load conditions, and reduced vehicle weight through advanced materials and structural analysis. However, the 1970s also marked the beginning of serious financial difficulties for Massey Ferguson. The company had expanded aggressively during the prosperous 60s, accumulating significant debt to finance new factories, distribution networks, and product development. When agricultural commodity prices declined in the mid-70s, farmer incomes fell sharply, and equipment sales collapsed, leaving Massey Ferguson with massive fixed costs and insufficient revenue. Why did the company struggle more than some competitors during this downturn? Management had been slower than rivals to recognize changing market conditions and had continued aggressive expansion, even as warning signs accumulated. The situation deteriorated throughout the late 70s and early 80s as global agriculture entered a severe depression. Farm bankruptcies accelerated, equipment dealers failed, and manufacturers found themselves stuck with huge inventories of unsold machinery. Massey Ferguson's debt burden became unsustainable, and in 1980, the company faced a crisis that threatened its very survival. Would this legendary brand that had served agriculture for over a century disappear into bankruptcy? The answer depended on convincing creditors, governments, and investors that the company could be restructured into a viable enterprise. The restructuring of Massey Ferguson proved painful but ultimately successful, as the company shed unprofitable operations, sold assets, and focused on core agricultural equipment markets where they maintained competitive advantages. New management brought fresh perspectives and a determination to rebuild the brand's reputation for quality and reliability. What lessons did the company learn from its near-death experience? That financial discipline mattered as much as engineering excellence, that global markets could be volatile and unforgiving, and that even legendary brands could fail if they lost touch with customer needs and market realities. The 1990s saw a revitalized Massey Ferguson competing effectively in increasingly consolidated agricultural equipment markets. The company introduced innovative designs that incorporated electronic controls, improved operator stations, and more sophisticated hydraulic systems. These advances made modern tractors dramatically different from the machines of previous decades. How different were tractors from 1990 compared to those from 1960? The gap was arguably greater than the difference between 1960 tractors and the horse-drawn equipment they had replaced, as electronics and hydraulics transformed tractors from mechanical devices into computer-controlled systems. In 1994, Massey Ferguson became part of AGCO Corporation, joining with other agricultural equipment brands in a new type of multi-brand manufacturer. This arrangement allowed Massey Ferguson to maintain its distinct identity and heritage while benefiting from shared engineering resources, manufacturing facilities, and distribution networks. What did this corporate structure reveal about modern agricultural equipment markets? That economies of scale had become so important that even major brands could no longer compete. effectively as standalone companies requiring consolidation and cooperation that would have been unthinkable in earlier eras. The 21st century brought new challenges and opportunities as agriculture faced increasing pressure to become more sustainable while feeding a growing global population. Massey Ferguson responded by developing precision agriculture technologies that allowed farmers to optimize inputs, reduce waste, and maximize productivity. GPS guidance systems, variable rate application equipment, and yield monitoring devices transformed farming from an intuitive art into a data-driven science. Why did these technologies matter so much for sustainability? Because they allowed farmers to apply exactly the right amount of seed, fertilizer, and chemicals to each specific area of every field, eliminating the wasteful blanket applications that had characterized earlier agricultural practices. Climate change emerged as perhaps agriculture's greatest challenge, creating unpredictable weather patterns, shifting growing zones, and increasing the frequency of extreme events that could devastate crops. Equipment manufacturers like Massey Ferguson found themselves developing machines for an uncertain future where farmers could not rely on historical patterns to guide their decisions. What specific features did tractors need for this more volatile climate? Improved traction systems for working in muddy conditions during unexpected wet periods, better cooling systems for extreme heat, and more robust construction to withstand increasingly severe weather events. Massey Ferguson also recognized that future farmers would look very different from previous generations. Younger farmers tended to be more educated, more technologically sophisticated, and more conscious of environmental impacts than their predecessors. Equipment needed to appeal to these changing values and expectations. How did this demographic shift influence design philosophy? Tractors became more like consumer electronics with intuitive touchscreen interfaces, connectivity features that allowed remote monitoring and control, and designs that emphasized efficiency and environmental responsibility alongside traditional concerns like power and reliability. The company's global reach meant that equipment needed to serve wildly different agricultural contexts simultaneously. A tractor sold in Western Europe might work small, intensively managed fields growing high-value crops, while an identical model in Brazil could be clearing new agricultural land from tropical forests or working vast soybean plantations. These different contexts created engineering challenges that required flexibility and adaptability. What specific features allowed one tractor platform to serve such diverse needs? Modular design that allowed different wheel sizes, varied ballasting options, interchangeable implements, and software configurations that could adjust performance characteristics to suit specific applications. Looking back across more than 170 years of history, what has Massey Ferguson's greatest contribution been? The answer goes beyond simply manufacturing equipment, important as that was. The company helped create and disseminate a vision of scientific agriculture where human ingenuity and mechanical power could overcome natural limitations. This vision transformed farming from subsistence survival to systematic food production, enabling population growth and urbanization that would have been impossible with pre-industrial agricultural methods. By the way, if you're interested in understanding how great machines were born, the industrial brands that dominated their era, and the technology that drove progress, this channel offers real stories every week that combine innovation, ambition, and mechanical power. Subscribe and discover the secrets behind the machines that moved the world. Let's pick up from here with the transformative decades that followed. Yet this transformation came with costs that are still being calculated. The mechanization that Massey Ferguson championed contributed to rural depopulation, the loss of traditional farming knowledge, increased energy consumption, and agricultural practices that sometimes prioritized production over sustainability. These negative consequences were not intentional, but they were real and significant. How should we evaluate a company's legacy when it includes both tremendous benefits and serious harms? Perhaps the fairest approach is to recognize that historical actors operated within their era's constraints and values, making decisions that seemed reasonable at the time, even if subsequent generations identified problems that were not apparent initially. The machines that Massey Ferguson built literally fed humanity, enabling food production at scales that previous generations would have considered miraculous. Famines that once killed millions became largely preventable through mechanized agriculture's productive capacity. This achievement alone justifies recognizing the company's historical importance and the engineers, workers, and farmers who made it possible. The tractors painted in Massey Ferguson's distinctive colors worked fields on every continent, operated by people of every culture, growing food that sustained billions of human lives across generations. What does the future hold for agricultural mechanization and companies like Massey Ferguson? Current trends suggest movement toward autonomous equipment that can operate with minimal human supervision, artificial intelligence that can make real-time decisions about plant health and treatment needs, and electric powertrains that could reduce agriculture's dependence on fossil fuels. These technologies promise another revolutionary transformation, comparable to the shift from horsepower to tractors that defined the early 20th century. Will farmers embrace these changes as readily as their predecessors adopted mechanical equipment? The answer likely depends on whether new technologies can demonstrate clear economic advantages while addressing growing concerns about sustainability and environmental impact. The story of Massey Ferguson ultimately reveals how technological innovation intersects with human needs, economic forces, and social change. The company succeeded not primarily because of superior engineering, though that certainly mattered, but because it understood what farmers needed and delivered reliable solutions at prices they could afford. This customer focus, maintained across generations and multiple corporate restructurings, explains how the brand survived and prospered for more than a century in intensely competitive global markets. The machines carried the Massey Ferguson name, but their real power came from understanding the people who used them and the work they needed to accomplish. As we conclude this examination of agricultural mechanization and the company that helped define it, we return to the question that began our journey. What drove Daniel Massey to believe he could revolutionize agriculture? Perhaps the answer is simpler than we imagined. He saw people struggling with back-breaking labor and insufficient productivity, and he believed that better tools could ease their burden and improve their lives. This fundamental impulse to help others through mechanical innovation animated the company he founded for more than 17 decades, producing machines that literally changed the world by changing how humanity grows its food. That legacy, built by countless engineers, factory workers, dealers, and farmers, represents one of industry's most remarkable achievements and reminds us that technology's ultimate purpose is serving human needs and advancing human flourishing. The legacy of Massey Ferguson extends far beyond the machines themselves into the very fabric of how modern civilization functions. Consider for a moment the cascading effects of agricultural mechanization on every aspect of human society. Without tractors and combines, would we have modern cities? Could universities exist in their current form? Would we have achieved the scientific and medical advances that define contemporary life? The answer to all these questions is almost certainly no, because mechanized agriculture freed the vast majority of humanity from food production, allowing specialization and urbanization that became the foundation for everything we consider modern progress. When Massey Ferguson tractors first appeared in developing countries during the mid-20th century, they represented more than just new equipment. They symbolized a pathway to prosperity and modernization that formerly colonized nations desperately sought. Government officials in India, Brazil, Kenya, and dozens of other countries viewed mechanization as essential to national development and food security. Why did these leaders place such faith in mechanical equipment? Because they had witnessed how mechanization transformed agriculture in wealthy nations and hoped to replicate that success in their own countries, believing that tractors could help them escape poverty and dependence on food imports. However, the introduction of mechanized agriculture into traditional farming societies created disruptions that nobody had fully anticipated. In many regions, tractors displaced not just human labor, but also draft animals that had been integrated into complex farming systems. Water buffalo in Asia, oxen in Africa, and horses across multiple continents had provided not only pulling power, but also manure for fertilizer, transportation for families and goods, and social status for their owners. What happened when tractors replaced these animals? Farming systems had to be completely reorganized, often requiring chemical fertilizers to replace animal manure, separate transportation systems for non-farming needs, and new sources of prestige and social differentiation in rural communities. The gender dynamics of agricultural mechanization deserve careful examination as well. In many traditional societies, women performed much of the agricultural labor, particularly tasks like planting, weeding, and harvesting. Men typically handled draft animals and heavy implements. When tractors arrived, they were almost universally operated by men, effectively transferring control of agricultural production from mixed gender systems to male-dominated mechanization. How did this shift affect rural women? Many found themselves marginalized from primary agricultural production, losing economic independence and social status that had come from their essential farming roles. Some transitioned to other economic activities, but others simply became more dependent on male relatives who controlled the new machinery. Massey Ferguson's engineers and managers were likely unaware of these social consequences, focusing instead on technical challenges of adapting equipment to different soil types, climate conditions, and crop varieties. The company established testing facilities in various regions to evaluate how tractors performed under local conditions. What did these tests reveal about equipment design? That assumptions valid in Canadian or European contexts often failed elsewhere, requiring significant modifications to cooling systems, air filtration, fuel delivery, and operator protection to make tractors reliable in tropical heat, desert dust, or monsoon humidity. The post-World War II decades also saw Massey Ferguson becoming deeply involved in international development programs. The company worked with governments and aid agencies to establish agricultural mechanization training centers, dealer networks, and parts supply systems in countries that had little experience with complex machinery. These programs represented substantial investments that would only pay off over many years. Why did Massey Ferguson commit resources to developing markets with uncertain returns? Company leaders understood that creating sustainable demand required building entire support ecosystems, not just selling individual machines. They also recognized that competitors who established early footholds in developing markets would enjoy long-term advantages as those markets matured and grew. The Cold War added geopolitical dimensions to agricultural equipment sales, as the United States and Soviet Union competed to win allies by demonstrating the superiority of their respective economic systems. Agricultural productivity became an ideological battleground, with both sides claiming their approach to farming organization and mechanization produced better results. Massey Ferguson, despite being a private company, found itself entangled in these struggles. How did this political context affect business? Strategy? The company had to navigate complex relationships with governments across the political spectrum, selling equipment to communist Yugoslavia and capitalist Brazil, to neutral India and NATO member Turkey, requiring diplomatic skills, alongside engineering expertise. The technological evolution of tractors themselves accelerated dramatically during the 1960s and 70s. Early tractors had been relatively simple machines with basic engines, transmissions, and hydraulics. By the 1970s, tractors incorporated sophisticated engineering that rivaled automobiles in complexity. What specific advances most improved tractor performance during this period? Turbocharged diesel engines increased power while improving fuel efficiency. Synchronous transmissions allowed operators to shift gears without stopping. And closed-center hydraulic systems enabled multiple, simultaneous functions with better control and less wasted energy. Cab design underwent revolutionary changes as manufacturers recognized that operator comfort and safety directly affected productivity and equipment longevity. Early tractors exposed operators to weather, noise, dust, and exhaust fumes, making operation physically exhausting. Modern cabs provided climate control, sound insulation, ergonomic seating, and improved visibility. Why did these seemingly minor improvements matter so much? Because operators who were comfortable and alert could work longer hours with fewer mistakes, while also enjoying better health outcomes and greater job satisfaction. The transformation of tractor operation from grueling physical ordeal to relatively pleasant work environment represented a triumph of human-centered design thinking. Massey Ferguson's research and development facilities employed hundreds of engineers working on everything from metallurgy to ergonomics, from hydraulic flow dynamics to electronic control systems. These technical specialists came from diverse backgrounds and brought different perspectives to design challenges. What distinguished great tractor engineers from merely competent ones? The best engineers combined theoretical knowledge with practical understanding of farming operations, spending time in fields observing how farmers actually used equipment and identifying problems that farmers themselves might not articulate clearly. This combination of technical expertise and empathetic observation produced innovations that genuinely improved agricultural productivity. The company also invested heavily in manufacturing technology, recognizing that building high-quality equipment required sophisticated production capabilities. Modern tractor factories bore little resemblance to the workshops where Daniel Massey had built his first implements. What were these factories like? They featured precision machining centers controlled by early computers, automated welding systems that produced consistent high-quality joints and paint facilities that applied multiple coats in controlled environments to prevent corrosion. Quality control systems tested components and assemblies at multiple stages, catching defects before they reached customers and maintaining the brand reputation that Massey Ferguson had built over generations. The dealer network represented another critical competitive advantage that Massey Ferguson cultivated carefully. Good dealers did much more than simply sell equipment. They provided financing options that made purchases possible for farmers with limited capital, offered maintenance and repair services that kept equipment operating reliably, stocked parts inventories so repairs could happen quickly, and served as trusted advisors helping farmers make appropriate equipment choices. What made someone a good Massey Ferguson dealer? Technical competence certainly mattered, as did business acumen and access to capital. But the best dealers also possessed deep understanding of local farming conditions and strong relationships within agricultural communities, allowing them to match equipment capabilities to specific customer needs. The cyclical nature of agricultural equipment markets created enormous challenges for manufacturers and dealers alike. Farm income depended on commodity prices, weather conditions, and government policies, all of which fluctuated unpredictably. When farmers prospered, they bought equipment eagerly. When incomes declined, equipment purchases stopped abruptly. How did Massey Ferguson cope with these violent swings in demand? The company maintained diverse global operations so that downturns in one region might be offset by prosperity elsewhere, developed product lines at multiple price points to serve customers with different budgets, and worked to maintain dealer relationships through difficult periods so distribution networks would remain intact when markets recovered. The rise of precision agriculture in the late 20th and early 21st centuries represented perhaps the most fundamental shift in farming since mechanization itself. Traditional agriculture had treated entire fields as uniform units, applying the same inputs everywhere. Precision agriculture recognized that soil conditions, moisture levels, and crop health varied significantly within individual fields. What technologies enabled this new approach? GPS systems allowed equipment to know precisely where it was located. Sensors could measure soil properties and plant health in real time, and computer controls could adjust application rates continuously as equipment moved across fields. Massey Ferguson invested heavily in developing and incorporating these technologies into their equipment. The data generated by precision agriculture systems created new questions about privacy, ownership, and control. When a tractor recorded detailed information about field conditions, planting dates, application rates, and yields, who owned that data? The farmer who operated the equipment? The manufacturer who built the systems that generated it? The software company whose programs analyzed it? These questions had profound implications for agricultural competitiveness and farm profitability. Why did data ownership matter so much? Because aggregated information from thousands of farms could reveal patterns and insights that provided significant competitive advantages, potentially allowing large agribusiness companies to optimize their operations while leaving individual farmers at an informational disadvantage. Massey Ferguson's approach to these ethical questions would help define the company's relationship with 21st century farmers. Would they treat customer data as a resource to be exploited for corporate benefit, or would they recognize farmers' ownership rights and privacy concerns? The company's decisions on these matters would affect trust relationships that had been built over many decades. What principles should guide corporate behavior regarding customer data? Many argued that farmers who generated the data through their operations should maintain ownership and control, with manufacturers and software providers serving as stewards rather than owners. Others suggested that the costs of developing and maintaining sophisticated data systems justified manufacturer claims to partial ownership of the information generated. Environmental sustainability emerged as another defining challenge for agricultural equipment manufacturers. Modern farming's productivity gains had come partly through increased inputs of energy, chemicals, and water, creating environmental impacts that were becoming increasingly apparent and concerning. Climate change, soil degradation, water pollution, and biodiversity loss were all linked at least partly to intensive agricultural practices enabled by mechanization. Did this mean that companies like Massey Ferguson bore responsibility for environmental damage? The question defied simple answers, as the same mechanization that enabled intensive agriculture had also prevented mass starvation and supported unprecedented human prosperity. Massey Ferguson responded to sustainability concerns by developing equipment that allowed more precise input application, reducing waste and environmental impact. Tractors with better fuel efficiency lowered carbon emissions per acre worked. Implements that minimized soil disturbance, reduced erosion, and preserved soil structure. Sprayers with improved targeting accuracy decreased chemical runoff into waterways. Were these improvements sufficient to address agriculture's environmental challenges? Most environmental scientists argued that equipment improvements alone could not solve problems that stemmed from fundamental aspects of industrial agriculture, requiring broader changes in farming practices, crop choices, and food system organization. The economic pressures facing farmers intensified throughout the late 20th and early 21st centuries, as agricultural commodity prices failed to keep pace with input costs and equipment expenses. Many farmers found themselves trapped in a cycle of debt, needing to expand operations and purchase larger equipment to generate sufficient income to service existing loans, only to take on additional debt in the process. How did this debt cycle affect farmers' relationships with equipment manufacturers? Some farmers resented companies like Massey Ferguson for selling increasingly expensive equipment that seemed designed to benefit manufacturers more than operators. Others recognized that manufacturers faced their own competitive pressures and cost constraints, viewing the situation as a broader economic problem rather than specifically an equipment industry issue. The consolidation of agricultural equipment manufacturing accelerated at the end of the 20th century and into the 21st. Independent companies that had operated for generations were acquired by larger competitors or disappeared entirely. Massey Ferguson itself had become part of the multi-brand ACCO Corporation, sharing engineering and manufacturing resources with former competitors. What drove this consolidation trend? The enormous costs of developing modern equipment with sophisticated electronics and precision agriculture capabilities made it increasingly difficult for smaller companies to compete effectively. Only large corporations with deep financial resources and global market access could afford the investments required to remain competitive. This consolidation raised concerns about reduced competition and market power concentration. When only a handful of companies dominated global agricultural equipment markets, would they abuse their position by raising prices, reducing product quality, or limiting service availability? Historical evidence from other industries suggested that oligopolistic market structures often led to exactly these outcomes. What safeguards existed to protect farmers from potential manufacturer exploitation? Antitrust regulations in various countries theoretically limited anti-competitive behavior, though enforcement varied significantly across jurisdictions. More importantly, farmers themselves often possessed considerable practical power through their equipment purchasing decisions and their ability to maintain and repair equipment independently. The right to repair movement gained significant traction within agricultural communities during the early 21st century as farmers chafed against manufacturer restrictions on independent repair and maintenance. Modern equipment incorporated sophisticated software that in many cases could only be diagnosed and modified using proprietary tools and information that manufacturers restricted carefully. Why did manufacturers limit independent repair capabilities? They argued that complex modern equipment required trained technicians to service safely and effectively, that protecting proprietary technology was necessary to justify research investments, and that unauthorized modifications could compromise safety and emissions compliance. Farmers countered that they had repaired their own equipment for generations, that manufacturer service was often unavailable or prohibitively expensive in rural areas, and that true ownership required the ability to maintain and modify property without manufacturer permission. This debate reflected deeper tensions about technology ownership and control in an increasingly digital world. When farmers purchased a tractor, what exactly had they bought? The physical machine certainly, but what about the software that controlled its operation? Did farmers have rights to modify that software to suit their specific needs? Could manufacturers disable equipment remotely if they determined it was being operated improperly? These questions extended far beyond agriculture, touching fundamental issues of property rights and corporate power in the 21st century. Massey Ferguson found itself navigating these contentious debates while trying to maintain positive relationships with customers whose trust represented the brand's most valuable asset. The company's response balanced competing considerations, acknowledging farmers' legitimate frustrations while explaining technical and legal constraints that limited what could be offered. What compromises emerged from these negotiations? Some manufacturers began providing more repair information and diagnostic tools to independent mechanics and farmers themselves, while maintaining restrictions on modifications that could affect safety or emissions. Whether these compromises satisfied anyone remained unclear, as both farmers and manufacturers continued pushing for outcomes that better served their respective interests. The globalization of agriculture created opportunities and challenges that would have been unimaginable to Daniel Massey in his 19th century workshop. Modern supply chains could move grain from farms in Ukraine to consumers in Egypt, soybeans from Brazil to livestock operations in China, and dairy products from New Zealand to grocery stores in the United States. This global integration meant that farmers everywhere competed in worldwide markets, their incomes determined by supply and demand conditions across the entire planet. How did this global competition affect equipment needs? Farmers required ever greater productivity to remain competitive with operations in regions that might have natural advantages in climate, soil quality, or labor costs. Equipment manufacturers responded by developing increasingly productive and efficient machinery, but this arms race of technological advancement pushed equipment costs higher while farm incomes remained volatile. The human dimensions of agricultural mechanization deserve continued attention, even as we examine technical and economic aspects. Individual farmers made decisions about equipment purchases that would affect their operations for decades. These choices required evaluating complex trade-offs between capabilities, costs, reliability, and brand reputation. How did farmers make these high-stakes decisions? Some relied heavily on dealer relationships and brand loyalty developed over generations. Others carefully researched specifications and compared options analytically. Many consulted with neighbors and agricultural advisors, seeking insights from others with relevant experience. The decision process revealed individual personalities and values, as some farmers prioritized cutting-edge technology while others preferred proven reliability. Operating modern agricultural equipment required skills that would have seemed impossibly sophisticated to earlier generations of farmers. Contemporary tractor operators needed to understand not just mechanical systems, but also electronics, software interfaces, and precision agriculture technologies. They monitored multiple information displays simultaneously while controlling various functions, maintaining awareness of field conditions and equipment performance. What preparation did this require? Many equipment operators attended formal training programs offered by manufacturers or agricultural colleges, learning both theoretical principles and practical skills. Others learned through experience and informal mentoring, gradually developing expertise through countless hours in tractor cabs. The seasonal rhythm of agriculture created intense periods of equipment use during planting and harvest, when weather windows demanded continuous operation to complete critical tasks. During these crucial periods, equipment breakdowns could cause catastrophic losses. What pressures did this place on farmers and equipment? Machines worked around the clock, operators pushed themselves to exhaustion, and mechanical systems operated at their limits. Reliability under these extreme conditions separated truly excellent equipment from merely adequate designs. Massey Ferguson's reputation had been built partly on understanding these seasonal pressures and engineering equipment that could withstand them. The relationship between equipment manufacturers and agricultural universities represented another important dimension of the industry's development. Universities conducted research that improved agricultural practices and evaluated equipment performance, while manufacturers funded research programs and donated equipment for educational purposes. What benefits did both parties gain from these relationships? Universities obtained resources that supported their research and teaching missions, while manufacturers gained access to cutting-edge scientific knowledge and maintained connections with future agricultural leaders. These relationships also created potential conflicts of interest when manufacturers funded research that evaluated their own products. Raising questions about scientific objectivity and independence, agricultural shows and demonstrations provided crucial venues where farmers could see equipment in operation and compare different manufacturers' offerings. These events combined carnival atmosphere with serious business, as families enjoyed entertainment while farmers evaluated purchases that might represent years of income. What role did Massey Ferguson play at these gatherings? The company invested heavily in impressive displays and demonstrations that showcased equipment capabilities, recognizing that positive impressions at agricultural shows translated into sales throughout the following year. Dealers worked the crowds, building relationships and identifying potential customers who could be contacted later with specific proposals. The emotional connections that farmers developed with their equipment often surprised outsiders who viewed tractors as merely functional tools. Many farmers spoke about their tractors with genuine affection, describing individual machines' personalities and capabilities with nuanced detail. Why did these emotional bonds form? Farmers spent thousands of hours operating their equipment, developing intimate familiarity with each machine's characteristics and idiosyncrasies. Tractors represented major investments that enabled farmers to support their families and maintain their way of life. Success and failures, good harvests and bad seasons were all experienced from the tractor cab, creating associations that transcended purely economic relationships. Before we finish, remember that we created this channel with one purpose in mind: to rescue the stories of heavy machinery that reveal how engineering, hard work, and industrial vision shaped our modern history. Because understanding these machines means understanding progress, human effort, and their impact on the world. Subscribe and become part of this community that loves to discover the secrets of the industrial past. Let's get back to the dramatic conclusion of this story. Massey Ferguson recognized and cultivated these emotional connections through marketing that emphasized heritage, reliability, and the partnership between farmer and machine. Advertisements featured real farmers in actual field conditions rather than idealized imagery, acknowledging the difficult conditions and high stakes that characterized agricultural work. What message did this marketing convey? That Massey Ferguson understood farming reality and built equipment specifically for the demanding conditions farmers actually faced, rather than for theoretical ideal scenarios that existed only in engineering laboratories. The stories that farmers told about their Massey Ferguson equipment contributed to brand reputation in ways that no advertising campaign could replicate. When a tractor reliably started every morning despite harsh weather, when it continued operating despite abuse and neglect, when it helped a family harvest a record crop or survive a difficult season, those experiences became narratives that circulated through agricultural communities. How powerful were these word-of-mouth recommendations? Marketing research consistently showed that peer recommendations influenced purchasing decisions far more than any other factor, making customer satisfaction the most valuable asset any equipment manufacturer possessed. Looking toward the future, what challenges and opportunities will define the next chapter of Massey Ferguson's story and agricultural mechanization more broadly? Autonomous equipment promises to transform farming yet again as tractors and combines that can operate without human supervision become increasingly viable. These machines could work continuously, making optimal decisions based on real-time data, potentially increasing productivity while reducing labor requirements. What concerns do autonomous agricultural vehicles raise? Safety questions about how these machines will operate around people and animals, economic anxieties about further reducing agricultural employment, and philosophical debates about whether removing humans from direct farming contact represents progress or loss. Electric powertrains represent another potentially transformative technology, as battery and fuel cell systems advance toward viability for heavy equipment applications. Tractors without diesel engines could dramatically reduce agriculture's carbon footprint while also offering operational advantages like quieter operation and lower maintenance requirements. What obstacles must be overcome before electric tractors become mainstream? Battery energy density must improve to provide sufficient operational range, charging infrastructure must be developed in rural areas, and costs must decline to make electric equipment economically competitive with conventional diesel machines. Climate adaptation will require equipment innovations that nobody can fully predict, as agriculture adjusts to changing temperature patterns, shifting precipitation regimes, and increased weather volatility. Farmers will need machines that can operate effectively across wider ranges of conditions, that can be reconfigured quickly for different crops and practices, and that help manage increased risks. How will Massey Ferguson respond to these evolving needs? The company's long history suggests it will continue doing what it has always done best, listening carefully to farmers, understanding their challenges, and developing practical solutions that help them succeed despite difficult and changing conditions. The story of Massey Ferguson ultimately teaches us that great companies endure not through technical superiority alone, but through sustained commitment to serving customer needs across generations and changing circumstances. From Daniel Massey's first workshop to contemporary precision agriculture systems, the underlying mission remained constant: helping farmers produce food more efficiently and reliably. This consistency of purpose, combined with willingness to adapt methods and technologies to changing times, explains how one brand could remain relevant and valuable across more than 170 years of dramatic technological and social transformation, continuing to serve agriculture and humanity through machines that quite literally fed the world and made modern civilization possible.